The angular displacement mini-lab involves two main components. One is the optical encoder, and the other is the encoder digital to analog converter. Now let's look at them one by one. In the housing of the optical encoder, there's a light source, which is generating a light continuously. Light travels and hits a disk. Half of the disk is transparent, and half of it is not. When the disk is transparent, the photosensor, which is on the other side of the disk, will be able to detect the light, indicated as a disk window. On the other hand, when the disk is not transparent, the light will not pass by, indicated as a disk line. Therefore, the end result of the optical encoder is a square wave. This square wave will be further fed into the second component of the system, digital to analog converter. The square wave itself is digital, and it serves as the input of the converter. Inside the digital to analog converter, first a digital counter will be counting how many square waves there is from the encoder, and then it will be converted to an analog signal. This analog signal is proportional to the angular position eventually. This is the system setup. The optical encoder is in the middle, and on the right, there's a digital to analog converter. Because the signal that gives out from the converter is an electrical signal, there's also a DMM. Now let's see how it works. This is gonna be our zero position, and DMM shows a very small value, 1.9 millivolt. This is a 90 degree for 2.6 volt. Notice what we are looking at is the relative position of the reflective tab on the rotary encoder. Keep moving. 180 degree for 5.17 volt. 270 and roughly 360 degree. Now we've got enough data to fill out this calibration table, from which we could draw a calibration curve. This is a sample calibration curve. Notice that we are using the angular displacement as x-axis and the output from the converter as y-axis. This way, the slope of the calibration curve becomes the sensitivity of the device, which has a unit of volt per degree. Finally, I would like to give you an example to show how to use the calibration curve and the sensitivity. We already know that the sensitivity of the device is 0.0275 volt per degree. And if the DMM reads 1.251 volt, this number divided by the sensitivity will give us how much the displacement is. This is about 45.5 degree. And now let's look at the tab. The position of the tab also shows about the same thing, which is around 45 degree angle.